YouTube. Today I'm going to show you how you can package your Python application into a Docker container. So I'm going to go over a little bit, why you would want to do that and why you should do that and why it's so awesome. And then once we go over all that kind of thing, I'm going to show you exactly how I have every project laid out, pretty much no matter what the project is. I use the exact same layout for my Docker file and my environment definitions. I'm going to show you how to build it, how to run it, and then finally how to remove it so that you can, not overtake all the space on your computer. So let's get right to it. I have this, also this README right here. I will link to this below, but it's really not too bad. It's just a couple commands. You'll see once you get used to it, it's really great. Okay, so first I thought I'd go over a little bit of why you should do this. And I think the number one reason why is just because once you learn how to, it's really, really easy. And then, you can take your application and you can put it in this nice bundle and then you don't ever have to worry about it again. So if you, frequently break your operating system like I do, you don't have to worry about it because you can just rebuild everything from a Docker container. You can build them, you can remove them. You can share them with coworkers, you can deploy them on AWS, you can deploy them on remote servers, really you can do whatever you want with them. And that is why they are so great. So, I use Docker extensively. I use it at work, I use it for personal projects. I try to get everybody that I know to use it. So, here we are. So the very first thing that I'm going to go over is the layout. This is the way that I like to have all of my Python Docker containers laid out. So, and you can see it right here too. So I have my project folder. You should name something more informative for your particular project. But at a minimum, I have a Docker file, I have an environment file, and I like to have a README. It's a good habit to be in to always write at least a little bit of documentation. So first I will go over the Docker file. Okay, so this is our Docker file. This is what is actually going to give Docker the instructions to build our custom image, which is what we are really going for. So with my IDE, every time you see something here highlighted in purple, these are specific instructions, okay? So I am building this from the base mini conda image, which is this. Conda is the scientific distribution of Python, and mini conda is a bit of a slimmed down version. I don't think it's significantly slimmed down, but we're gonna do that. And then the format is, I don't know, kind of like group, whoever is distributing it, the name of image, and then just a tag. And a lot of times you'll see this tag is latest. But I don't recommend doing that. I really recommend that you actually tag the image that you're using, because I've just had so many times where I've built something and I didn't tag the exact version that I was using, and then it was pain and heartache and tears, and save yourself, pin versions. So once we define our base image, maybe you don't even want to use this, maybe you just want to go really bare metal and use something else, but I like this one. You want to start to actually run some commands. So that's when you see run right here. So the mini conda image is based off of the Ubuntu image. So I'm just going to run apt-get update upgrade, and I am going to install Vim and SSH. If you don't ever use Vim, I would kind of recommend leaving these off, but I kind of like to have them everywhere. It just makes things a little bit easier for me. And then the very first thing that I'm going to do is I'm going to copy my environment.yaml from the host to the container. And this is the way that it always is. It's always copy relative to, well, it's actually relative to where you're building, and then the working directory in your container. And you could also specify this too. You could say, like this. If you don't, it's your current working directory, just like it is in your normal shell. All right, so then after this, I'm going to tell conda to conda env create my environmental variable or my environmental file. And this is just kind of a nice bash alias that I like. You can completely ignore that if you like. So then, we'll install it. And then next up will be that I want to actually activate it, and I want it activated in my shell, so I'm going to add this to my bash RC. And if you've ever used source activate or conda activate or virtual env, I forget what that was, activate or something like that, all that these are doing is that they are just sourcing some environmental, they're setting some environmental variables for you. So, and kind of a handy way to do this, if you ever need to do it, is to just run, just in your shell, you can just run, env, and then you could do like source activate, you know, in this case it's Python app. Yeah, like if you ever have to do this for anything else and you want to see what environmental variables are being set, you can always just do env, which is going to dump out all of your environmental variables, activate your thing, or module load, or virtual env, or whatever it is that you're doing, and then run env again, and then you could even just do diff. Okay, so for right now, like this. So for right now, you don't need to do that because I already know all of these and I have them in here for you. But if you want to verify it or learn how to do it yourself, this is pretty much what I always do. So I'm going to say the conda exe, which is the main conda executable. It's already in the container because we're using the base mini conda image. If you're using a different image, just make sure that this is the correct one. The conda prefix, this is the prefix to the environment that we installed. The conda Python executable, is the path to Python. Our conda prompt modifier is the modifier that we want to use, which is it's a handy kind of way of showing you like, okay, this is the environment that I'm working on. I will show you what this looks like in a little bit. The default environment is this Python app. We only have one. I suggest that you have one environment per container because that's a nice way to do things. And then I'm also just going to ensure that this environment is in fact sourced in my path. And so there we go. Now that we're there. Oh, and then I wanted to show you the environment definition file. If you haven't used these before, these are really, really great just because they're so clear. And if you're ever handing it off to somebody, they don't even have to know what any of this is. You could just say, okay, here's a project, give it to them in a zip, and tell them you change whatever packages you want here, okay? So then they can add, or you can add pandas or sklearn or any of this kind of stuff, anything that you want. Okay, so this is why I like to do this. So we have our name. Actually, this is kind of an important point. So if you see this name, this also has to match the name that we give it here. So if you change it here, just also ensure that you do, like a string replace in here. Okay, so it's here, 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 here. All right, and then you have your channels. I pretty much always have Conda Forge defaults, BioConda if I'm doing work stuff, dependencies, Python 3.6, IPython. I always really like to have IPython installed. If you prefer Jupyter Hub, you're probably going to want that instead. Just, go with whatever kind of you're used to, whatever you work with. And NumPy, just for the sake of demonstrations, I'm going to show you some things once we get this actually up and running. Okay, so now that we have our project set up, again, we have our project folder, we have a Docker file, we have our environment definition, we have something that could potentially constitute documentation. Then we can go and we can build our image. So I'm just going to show you how to do that. So docker build -t numpy python. Okay, and what this is you're telling Docker, build this thing, give it this tag. The tag is just a human readable name. Underneath the hood, Docker assigns your container some like big long string that you never want to actually have to remember. And then dot means this is the build context. You're finding the Docker file in this directory. And there we go. Okay, so I'm going to pause this and let this go, and I will come back and show you how it worked. Okay, so we're back. Here we go. All right, so this built. I'll go all the way back up to the top here. Okay, I'll make this a bit bigger too. All right, so I told Docker build -t numpy python, and that the build context was here in this current working directory. And it says, you know, it's all good here. If you don't already have this Docker image installed locally on your computer, it will pull it for you automatically, so you don't need to worry about that, which is a really nice thing about running Docker too, is you don't have to worry too much about the dependencies. It does a really good job of pulling those in for you. So, you know, I ran my things and I copied my files, and then I ran conda-env create, which actually got us some outputs. Maybe that one is a little bit more interesting. And you can see that it installed a bunch of packages for us. And then it also says, hey, to activate this environment, use source activate Python app, which we already know because we already have it in our Docker file. So this is great. You know, and then the environmental variables, those don't take very long. Okay, so let's just clear this out. And now that we have this, we want to actually start to be able to use it. So I'm going to say docker run. --rm is just telling Docker to like clean up after itself. Otherwise, it keeps a lot of copies of a lot of things around that you probably don't want to have and you just don't want to mess with. So just tell it to remove things. Docker run --rm. -I is interactive. T is tty, which means give us a shell. And then the name, the tag of the container that we used earlier. And bash, because I just want just an interactive shell. Okay, so this here is our conda-env prefix, which we saw earlier in the Docker file, right? Or the conda prompt modifier, right here. See, so you can see it comes up here. And this means, if you see this, it means that you're able to load your environment. You didn't get any of the variables wrong. Or I didn't get any of the variables wrong, and you're all good. Okay, so now I am gonna call IPython, because that's pretty much my favorite thing to do whenever I have a Python container, is to just open up IPython, and then I'm gonna import NumPy. And you can see I have, you know, all my usual things that I have. You know, I have my completion and everything, right? N is equal, you know, so if I want to tell NumPy, just get me a random array. This is what I do. And then, you know, and here's my random array, and we're all good. Okay, so hopefully that showed you how you can use this like as a development environment. You can, you know, you can just specify your packages here, build it, spin it up, start running some commands. It will save you a lot of heartache in terms of running things on your, or installing things on your local computer, because, you know, that just gets so messy so fast. So I'm going to exit this, and I am going to show you a few other things. So what I want to show you next is, okay, so we ran, I'm going to show you how to just execute a command. Just a one-off command instead of a shell. So you saw how we could run the container and just get like just a regular shell. But I am going to show you how you can run just, you know, just a single command and then have it exit. Okay. So I ran this. I said echo hello world, and it echoed everything for me, right? Or it echoed, you know, it echoed what I told it to. And this is great. So what this means is that like you could actually create a Docker container that in itself has a CLI, so a command line program. You could package that up and then you could give it to your coworkers or other people that you work with. on personal projects or whatever. They don't have to install anything locally to their computer except for Docker, and they can run, they can run your program without having to worry about what version of Python they're on, or what kind of other things they have installed on their computer, or versions of GCC or whatever. They don't have to worry about it. They can just run it just as is. Okay, and that is really, really cool, especially for programs that are like really, really hard to install, which seems to be a lot of scientific applications are very difficult to install, which I know because I managed to make basically a career out of that. Okay, and then the next thing that I want to show you is how you get access to your file system. And when I say your file system, I mean the computer you are actually working on, like your host computer. I'll leave that up for a minute. Your host computer. So, for me, that's here. Okay, so generally the way that I do this is, I say docker run -it, and then the -v is for volumes because we are going to bind some volumes. And I always just mount this as just my current working directory, and then also in the container is my current working directory. So this is always going to be, everything in Docker is always host container. So if you remember in our Docker file, when we had to copy our files, it was copy host container, right? This is the same thing, host container. Okay, so now I'm going to do the same thing. I'm going to just run an interactive shell. And then I'm on a Mac, so I'm users, Jillian, all kinds of stuff. And then build Python app Docker. Okay, and you can see this here, I'm in my container, and these are the same files that show up on my host system. And just to kind of really prove this point, what I'm going to do is I'm actually going to edit a file in the container. Okay, come on, update. Oh, see, and then here you go. It also updates right here. So I edited this from the container and I misspelled that, but that's okay. See, so you get this. Right, so this did actually show up here, or this was actually mounted and I was actually able to edit files in real time. All right, so that is what I was looking for there. Okay, so now I want to demonstrate something else about data persistence. Data does not persist in Docker unless you very explicitly tell it to. Generally, if you want to persist data, you want to do it through file mounts. There are other ways to do it, but that is kind of the simplest way to do it. And that's what I just showed you just here through this binding. So, I'm gonna, just to demonstrate that, I'm gonna make a directory. I made the directory /app. I'm gonna exit this container, and I'm gonna run it again. And I'm gonna show you that that container does not exist anymore, or that directory doesn't exist anymore. So you can see here, I made the container, I keep on saying container. I made a directory. I exited the container. And then I went into the container again with the same tag, but it's not exactly the same container, but it's close enough, so here's the same container for me. I tried to access this directory and it doesn't exist because Docker does not persist data unless you explicitly tell it to. And that's just it. So if you wanted to have something called app, you would have to actually bind another volume, I don't know, users, Jillian, and I could bind that as app. Right? I don't actually want to do that because I don't really want my entire home directory in Docker, but you could do that. So that is that. And then hopefully you've seen how you can run you know, one-off commands and have the container exit, how you can run a command and actually jump into an interactive shell. And then the very last thing that you want to do is you may or may not want to remove it. At some point, it's really easy to have like Docker take up just a ton of space on your file system. And so, you know, you do want to remove things every once in a while. Okay, and then you can see I removed this container. First it untagged it, then it deleted all these things. This one doesn't show you how much space you cleaned up. If you really want to go nuts and you want to remove like everything, like you have way too much stuff on your file system, you can say Docker system prune. I don't have anything good right now, but generally it will remove things, and then it actually shows you what you removed, and then it shows you how much space you actually cleaned up. So that was it. I'm hoping that this was useful for you. Thanks for watching. Bye.